Hi guys, welcome to today's tutorial. Today we'll be looking at trigonometric identities. So stay with us as we get right into it. Alright, on trigonometric identities, we have sin²θ plus cos² equals 1 and 1 plus cos² equals cosec² and 1 plus tan² equals sec²θ. Tan² is also sin² over cos²θ. Now looking at our trigonometrical formulas, we have for the addition and subtraction ratios, sin A plus B equals sin A cos B plus cos A sin B. You can notice the interchange. Sin A cos B sin B. Now, on look at same for the subtraction, it becomes sin A cos B minus cos A sin B. Now, for the cosine, if we have cos A plus B, it's giving us cos A cos B. Now, the cos are on both sides and the sines are on both sides. But now, if you're having a plus, you're doing a minus. And if you're having a minus, you're doing a plus. Now, I'm talking about tan A plus B will give us tan A plus tan B divided by 1 minus tan A tan B. While if you say tan A minus B, we're having it as tan A minus tan B divided by 1 plus tan A tan B. Now we are going to look at examples on how to use some of our, there are other numerous trigonometrical formulas, but due to space, we can't write all of them out. So we'll look at examples. The more examples we look at, the more of the formulas will be applied. So stick with us as we go right into examples. Our first question says, show that 1 minus sinθ over 1 plus sinθ equals secθ minus tanθ all squared. Now, in order to solve this, we are going to multiply both a numerator and denominator with 1 minus sinθ. So this gives us 1 minus sinθ all over 1 plus sinθ, okay, times 1 minus sinθ all over 1 plus 1 minus sinθ. Okay. Now, expanding this will give us 1 minus sinθ all squared, okay, all over 1 times 1 is 1. This times this will give us, this times this will give us minus sinθ plus sinθ minus sinθ squared, okay, or sin²θ, whichever. Alright, so this we cancel out, leaving us now with 1 minus sinθ all squared all over 1 minus sinθ all squared, because 1 squared is also 1 squared. Okay, sorry, this will leave us with 1 minus sinθ squared. Okay. Alright, now having this as this, we know that from a trigonometric function that we just saw, we know that 1 sin² plus cos² equals 1. So 1 minus sin² equals cos²θ. Alright, now knowing this, we can replace this with cos²θ. So this gives us 1 minus sinθ all squared all over cos²θ. Now, having done that, we can now separate our cos. Okay, since it's cos²θ, we can now share that cos to both sides. Now this will be having us 1 over cosθ minus sinθ over cosθ all squared. Okay, and we know that 1 minus 1 over cos theta is our sec. So we know that sec theta equals 1 over cos theta, and sin theta over cos theta equals tan theta. So now replacing this becomes sec theta minus tan theta all squared. Now we've been able to prove that 1 minus sin theta plus 1 cos sin theta 1 plus sin theta equals sec theta minus tan theta all squared. Our next question says, simplify sin theta over 1 plus cos theta plus 1 plus cos theta over sin theta. Now, in simplifying this, first off, we take our LCM. Our LCM here will become sin theta bracket 1 plus cos theta. Okay? Now, if we have this as our LCM, 1 plus cos theta here will be left with sin theta. So this becomes sin theta times sin theta. Alright? Now, sin theta here will be left with 1 plus cos theta plus 1 plus cos theta times 1 plus cos theta. Okay, now having done that, now we know that sin theta times sin theta will give us sin²θ plus, expanding this is 1 plus cos theta plus cos theta plus cos²θ all over sin theta 1 plus cos theta. Okay, now adding a numerator, we have it as sin² plus 1 plus 2 cos theta plus cos² all over sin theta 1 plus cos theta. Okay, now having done that, we can now open up our bracket and look for how to collect like terms. Okay, now we know that from here, if we open up this bracket, we have it as sin² plus 1 plus 2 cos theta plus cos² all over sin theta bracket open 1 plus cos theta. Okay, now if we collect like terms here, we know that sin²θ, recall that sin²θ plus cos² equals 1. So this plus this will give us 1. So rewriting it here, we have it as 1 plus 1 plus 2 cos theta all over sin theta bracket 1 plus cos theta. Okay, now from here we can now collect like terms. This will give us 2 plus 2 cos theta all over sin theta bracket 1 plus cos theta. Okay, so this will give us 2 bracket 1 plus cos theta. Okay, so if we factorize this, we remove 2 from here, so it's remaining 1 and 2. So over sin theta 1 plus cos theta. Now at this point, we can cancel out our 1 plus cos theta. This can cancel this, leaving us with 2 over sin theta. Okay, and we know that sin theta, we know that 1 over sin theta is cosec theta. Okay, 1 over sin theta is a cosec theta. So this is something as 2 times 1 over sin theta, which will give us 2 cosec theta as our answer. So the answer, if simplified, will give us 2 cosec theta. If sine x equals 5/13 and our x lies between 0 and 90 degrees, which is in the first quadrant, that means both cosine and tan are positive. Now it says find sec x times tan x. Now we are given sine x equals 5/13. Okay, if we have our Pythagoras theorem, this is sine is opposite over hypotenuse, opposite over hypotenuse. All right, that means on our triangle, our hypotenuse is 13, and let's call this x, and our opposite is 5. Now, if we apply Pythagoras rule, we can find our adjacent, which is 13 squared minus 5 squared, all right, which will give us 12. Okay, now if we do that, our adjacent will be 12. Now we know that from our trigonometric function, we know that we are having secθ equals what? 1 over cos x, okay, cosθ. Sorry. Now in this question, our theta is x. So our secθ will become x. So this becomes cos x. And we know that tan x is sine x over cos x. Okay. Now, having this in mind, we can now find our what's our cos x? Our cos x will become adjacent over hypotenuse 12/13. Okay, so knowing that our cos x is 12/13, we can now decide to do our sec x times tan x will give us 1 over cos x times sine x over cos x. Okay, now this we are going to have it as 1 sine x over cos squared x. Okay, now bearing in mind that our cos squared x equals 1 minus sine squared x. Okay, so now since we have the value of sine, okay, and we have the value, and we have our 1, we can now rewrite this to be sine x over 1 minus sine squared x. Now solving out this with the value we are giving, this will give us 5/13, which is our sine x, all over 1 minus 5/13. So if we do our workings on our numerator, on our denominator, our LCM will be 13. This will give us 13 minus 5, which will give us 8/13. So if we have it as, this should be 5 squared, all squared, because it's sine squared. Sorry. Now, this will give us 5/13 all over 1 minus 25/169. Okay, so having it as 25/169. So now our LCM here will become 169, right? 169 minus 25, which will give us 144/169. All right, now bringing it back to this question, we have it as 5/13 all over 144/169. So our inverse will give us 5/13 times 169/144. 13 here 1, 13 here 13. So 13 times 5 will now give us 65/144 as our answer. Now, we've gotten 65 over 144 as our answer. Now, let's look at applying this method, whether we would get same answer. Applying the method of, we are having 1 over cos x times sin x over cos x. Now, 1 over cos x is 12 over 13 times sin x, 5 over 13, all over 12 over 13. Now, if we do this, this becomes 13 over 12 times 5 over 13 times 13 over 12. 13 cancels 13, leaving us with 13 times 5 all over 12 times 12. So this still gives us 65 all over 144 as our answer. And next question says, simplify sine 45 plus theta minus sine 45 minus sin theta. Now remember, when we started, we have sine A plus B to give us sine A cos B plus sine cos A sin B. Okay, and on the other hand, we have sine A minus B to give us sine A cos B minus cos A sin B. Now, applying this here, this is for positive, this is for negative. So this becomes sine 45 cos theta plus cos 45 sin theta. All right, that's for the first part. Now, minus second part, sine 45 cos theta minus cos 45 sin theta. All right, from here, we'll do what? Let's open up this bracket and collect our like terms. Okay, so if we open up our bracket, we are having sine 45 cos theta plus cos 45 sin theta minus sine 45 cos theta plus cos 45 sin theta. Now you can see we have cos 45 sin theta plus cos 45 sin theta, and this positive sin 45 minus sin theta and this. So we can cancel out, those two can cancel out. Okay, these two will cancel out. This will cancel this, leaving us with 2 cos 45 sin theta. Okay, now we know that in our trig function we have cos 45 as 1 over 2, 1 over root 2. Okay, our cos 45 is 1 over root 2, so this gives us 2 times 1 over root 2 sin theta. Okay, one will calculate 45 from using our special angles. Okay, remember we have our special angles this way, where this is 45, 45, 90. Okay, now this is an equilateral triangle. Okay, so this is 1, 1. So this will become 1 plus 1 equals x. So our x here will become x squared. So x will become root 1 plus 1, which is root 2. That's how we got this. Okay, and cos is what? Adjacent over hypotenuse. So if our hypotenuse is root 2, our cos 45 will become 1 over root 2. That's how we arrived at cos 45 as 1 over root 2. Alright, now having said that, now the next thing we are going to do, this will give us what? We are going to factorize or rationalize our denominator. Okay, if we rationalize our denominator, we are going to have it as, if we rationalize our denominator from here, we are going to have it as 2 over root 2, 2 sine theta over root 2, okay, times root 2 over root 2. So this will give us 2 root 2, okay, sorry, 2 sine theta root 2 all over root 2. Root 2 times root 2 will give us root 4, and root 4 is 2. So this gives us 2. So 2 cancel 2, leaving us with root 2 sine theta. Now with this, we've simplified our equation. Our next question says simplify 2 sine 75 cos 15. Now, it's important to know that in doing this, we are going to have it as sine A plus B minus sine A minus B plus sine A plus B. Okay, now if we have it at that, where our sine A is 75, okay, so this becomes sine A is 75 and B is 15. So this becomes sine A, which is 75, minus 15 plus sine 75 plus 15. Okay, so this will now give us sine 60 plus sine 90. And we know that from our special angles, sine 60 is root 3 over 2, and our sine 90 is 1. Okay, sine 90 is 1. Now, knowing this, we're applying it here. This becomes root 3 over 2 plus 1. Okay, now finding our LCM here, this becomes 2 root 3 plus 2 here 1, okay, 2 here 1, 1 here 2. So 1 times 2 will give us 2. So this becomes root 3 plus 2 over 2, which can be rewritten as 2 plus root 3 over 2. So whichever way, you're still correct. Alright guys, with this, we've come to the end of today's tutorial. Don't forget to like, subscribe, click on your notification buttons for more updates. If there be any questions, put them down in the comment section below. Thank you.